Alright, so we're going to do a quick lesson on vectors, different types of vectors. Specifically, we're going to look at displacement and velocity. We had talked about in class what a vector is. A vector is a quantity that has direction and magnitude. We saw that little clip from Despicable Me. Although it was silly, it really did make a good point. Vectors have two things. They have displacement, vectors are two things. They have magnitude and direction. I think I misspoke earlier. Direction and magnitude are the two things that all vectors have. Here are some quick notes. You can pause the video here and take them down real quick, or summarize them would be better. Summarize them in your own words. And here are some just quick notes. I'll pause and let you write those. So we have, first of all, here is displacement. Displacement is similar to a distance. It's just sort of a vector. So it's a vector quantity describing the position of an object relative to a point of reference. So displacement tells me where I am relative to something else, and it's measured in meters. So right now, maybe I'm 7 meters from 7 meters east of the wall, or maybe I'm 30 miles south of Bowling Green. I guess a little less than that, but something like that, 30 miles south of Bowling Green. Displacement is measured, and it's a vector because it has a direction in there. Velocity is also a vector, and it's going to be very similar to speed, and we're going to look at how it's similar to speed, but vector quantity describes the rate. It's a vector quantity describing the rate that an object is changing position. So it's basically speed with a direction that makes it a vector. We have a convention that north and east are positive, west and south are negative. And there's not any specific reason why they're positive or negative. I think it is related to the Cartesian coordinate planes. This is a positive direction, that's a negative direction, positive direction, negative direction. But this is just sort of a convention. So when we write down different vector quantities, we'll usually use a positive or negative number to indicate the direction. For example, if I was going to describe a velocity of 10 meters per second, if I put 10 meters per second east, then we would consider this to be positive 10. So it's just 10. But if I wanted to talk about 10 meters per second west, we would consider that to be negative 10. And these, of course, are meters per second. No naked numbers. And these are the two different ways we could write that. So the positive direction and the negative direction. So we can use positive and negative to represent the different directions when we talk about vectors. Here's how we're going to calculate velocity. Again, go ahead and pause the video so you can get this down, and I'll pause as well. So up here we have this is how we really calculate velocity. And let's talk about this little triangle here. It's actually the Greek letter delta. So delta is a Greek letter, and it's the Greek letter D. So if I was going to write my name, Daniel, it would start with delta. In college, I would say that I was going to start my own fraternity. It's going to be Delta Alpha Nu, D-A-N, Dan. But anyways, delta is a Greek letter, and you may have seen it before in your math classes. When we talk about delta, delta represents the change in something. So this x is the displacement. So we're defining the velocity as the change in displacement divided by the change in time. Now, if you're going to calculate the change in something, you have to know where it began and where it ended. And you take the difference between those two. And that's exactly what you have here. The final displacement minus the initial displacement. And that's exactly what we see here. On the bottom, I've written the time, just sort of as the time it takes. A lot of times you're not going to be told, okay, we started at 0 seconds, we ended at 10. We started at 0, we ended at 8. You're always starting at 0 pretty much. So really this kind of becomes, let me show you another way to write this. The velocity could be written as the final displacement minus the initial displacement divided by the final time minus the initial time. And this would be absolutely correct, and an absolutely correct way to write it, a great way to write it. It's just that most of the time your initial time is 0, so if this thing is always becoming 0, you might as well just kind of leave it off. But again, understand that it is the change in displacement divided by the change in time. And actually, I know you've talked about slope before, right? Slope. You usually talk about rise over run, or y2 minus y1 over x2. You could also think about it as the change in y And this is the way you would, I think if you look up on Wikipedia, it's probably the way it's written. The change in y divided by the change in x. So delta notation gets used a lot in mathematics, and we do use it in physics as well. It's the change in displacement divided by the change in time. But again, this is how we basically calculate it. So let's compare velocity and speed real quick. It says a man walks 8 meters south in 16 seconds. What is his speed? So this is simple enough. Speed is distance over time, right? You can use your little triangle that you should have. So speed is distance over time, so it's going to be 8 meters over 16 seconds. Well, 8 divided by 16 gives me 0.5 meters per second. And that would be my speed. Let's see how it compares to velocity, though. Velocity, from our previous notes, is the change in displacement divided by the change in time. Or in other words, the final displacement minus the initial displacement divided by the final time minus the initial time. In this case, my final displacement, I'll end up 8 meters south. But be careful, when I write this, again, displacement is a vector. So since this is south, I'm not just going to write 8, I'm going to write -8 because it was south, 8 meters south. So here I've got -8 to indicate the direction, minus I began, well, you don't really say where you began, so we just assume we began at 0. Divided by the final time, it took me 16 seconds, minus I began again at 0. You see why we kind of leave this off a lot of times. So you have 8 minus 0, -8 minus 0 gives me on top -8. And of course that's my phone ringing. Oh no, nobody ever calls me, I don't know why. Oh. That was the alarm to tell me to make the video, so I'm a little ahead of schedule here. -8 minus 0 over 16 minus 0. Okay, I just rewrote everything. Sorry, I'm distracted. Again, -8 minus 0 is just -8 over 16 minus 0 is 16. So when I divide that, I get -0.5 meters per second. Or in other words, again, this is a vector, so that negative tells me a direction. This tells me I'm 0.5 meters per second south, and that is my velocity. Velocity is a vector. It has a magnitude. Here I'll circle the magnitude in green. The magnitude and direction. I'll circle direction in black. So that's what makes velocity a vector. Alright, and I think I'm going to go ahead and end the video here. Again, if you have friends who have not watched the video yet, you should tell them to watch it before class tomorrow. Thank you.